Ars Electronica home delivery. While you can't come to us, we come to you. So it is a pleasure for me to welcome you to our episode live from Deep Space 8K at the Ars Electronica Center. My name is Michaela, and for this episode I have a very special topic for you. It is 3D laser scanning on the example of a beautiful bridge here in Linz that does not exist anymore, the old railway bridge across the Danube. And you can already catch a glimpse at the bridge behind me here at the projection. And what is really special about this 3D laser scan project is I have an Xbox controller here, and I can control our journey over the bridge and around the bridge here in real time. But at the moment, you might have the impression that the image here is blurry. This is simply because it's a 3D projection, which means we project two images, one for the right eye, one for the left eye. And normally our visitors here in Deep Space have these 3D glasses, and then they have a three-dimensional vision. Yeah, and this means now at the moment, as you can't come to us, I will put on these glasses, but as well we have glasses for the second camera here in the room, so that you at home can have a beautiful, sharp image here and travel with me over the bridge. So I'll go to the background now, and we switch to the other camera. So, and here we are, right on this old railway bridge. And what was really special about this bridge is the style in which it was built. Now, look a bit closer what you see here. It's a framework bridge. It's built out of riveted iron, and this is actually the style that could be compared to the Eiffel Tower in Paris. So the bridge here was opened in the year 1900, and that was a typical style in architecture back then. Yeah, compare it to the Eiffel Tower. That was opened in 1889, just 11 years before this bridge here. And framework bridges are pretty rare worldwide. One reason why many of them had to be demolished already is the simple fact that iron gets rusty over the time. And this is exactly what happened with the bridge here in Linz. And for quite a long time, the bridge was listed as a protected monument, and it was owned by the ÖBB, the Austrian Railway Corporation, that was privatized then in the 1990s, and then the protection of the bridge was set aside, and then in 2002 it was enacted again because, of course, it is a cultural heritage in a very special architectural style. Yeah, and then, of course, the bridge got more and more rotten, was in a really, really dangerous condition already. You must imagine there were trains crossing the bridge here, which is really a heavy load to carry for a bridge. And so then in 2016, 4 years ago, the bridge was demolished. And as we take a look from the side at this bridge, you can see it was really beautiful. 3 beautiful iron bows, about 400 meters long, all in all. And actually, it was a decision of the citizens of Linz that the bridge should be demolished and a new bridge should be built. Yeah, and this 3D laser scan was done in 2016, shortly before the bridge was demolished. And 3D laser scanning is such a helpful technology for the digital preservation of cultural heritage. And maybe you wonder why we're walking through point clouds, more or less. You can see tiny points here, millions, billions, or even trillions of points. Yeah, that's the technology. A laser scanner is quite a small object. You can see a laser scanner here on a tripod right in front of us. And a laser scanner sends out laser beams into every direction, and it can extremely accurately measure in which distance to itself this laser beam encounters an object. And thus you scan three-dimensional objects, and this is a very precise method, a very precise technology. So the modern generation of laser scanners performs up to 10,000 points of measurement per second. And this scan here is a pretty raw data set. You can see that there are people who were actually doing the scan visible on the bridge. And this can be, of course, corrected, and in post-production you just delete them to have a clearer view here. But we left the raw data set here because it's quite interesting to walk through the points and understand a bit better how laser scanning functions and works. Yeah, and as the bridge is quite a complex building, it was necessary to scan it from 70 different scanning points, which was more or less a hard day's work. And then you have 70 data sets. And to put them together into one file, you need these white balls that you can see on tripods as well. They were not originally on the bridge, of course. These are part of the laser scanning process. So they mark the start and the end of one data set. And it looks as if there were hundreds of balls here mounted on the bridge. But that's, of course, not the reason, because each data set only has got a handful of them. It's just the impression that you have when you walk through all these files here, more or less. Yeah, and 3D laser scanning is used in the field of preservation of cultural heritage, of course. And this is necessary. It is used worldwide, because when you think of cultural heritage sites, UNESCO sites as well, that were already damaged or destroyed, then it is important to have at least a digital representation of these monuments. If you think of the Near East at the moment, like for example in Syria, the Roman city of Palmyra was destroyed by IS troops. And that was a monument or a site that was listed in the list of UNESCO World Cultural Heritage Sites. But it's lost forever, more or less. And with 3D laser scanning, of course, we have no substitute for the real objects, but at least the digital representation. And here in Ars Electronica Center, in our deep space, our presentation room, we have this great opportunity that we can kind of experience the feeling, how it must have been to visit sites that don't exist anymore. Yeah, and this scan was made by a company from Upper Austria, EF Tech, in cooperation with the Ars Electronica and the Linz AG, were responsible for any public areas of the city of Linz also. And some funny details also here. You might wonder why there are single points that have no relation, no connection to the bridge, these white ones in front of us, for example. And that was a bird, a seagull, just flying over the bridge. So as the bird moved, only a few laser beams could detect it, could scan it, and you can see really the trace of the bird here. And also quite interesting that the whole surrounding was also scanned, so that you have a better imagination where this bridge actually was. So the closer surrounding. And what is also very helpful with the modern generation of laser scanners is that you also have color information. It's not the mere point of measurement. There's also color, like the graffitis here in the little park. Yeah, so one of many projects that we can present here in Deep Space. So watch out for other presentations of laser scans. For example, the Great Pyramid in Giza was already presented. You will find this presentation on YouTube. Just check out our Ars Electronica YouTube channel and you will find other presentations that deal with this topic. Yeah, and at this point I say thank you very much for your attention. Thanks for joining us, and hope to see you next time when again we can say you can't come to us at the moment, we come to you with Ars Electronica home delivery. Goodbye.